one last vector function tailor-made for describing planes, the cross product. Take your right hand, if your two fingers are vectors, your thumb is the cross product. Two vectors, the cross product, which is orthogonal to both vectors. And one further, the area of the parallelogram made by those two vectors is the length of the cross product. To compute this magic vector, we take the 3 by 3 determinant. If you don't know what that is, I will show you. Cover up row and column, and you have a 2 by 2 determinant. You alternate the sign. The 2 by 2s, you add going down and subtract going up. Main diagonal, positive. Minor diagonal, negative. Main diagonal, positive. Minor diagonal, negative. There's your cross product vector. A point and two vectors make a plane. The cross product is orthogonal to any other vector in the plane. To describe the plane, we take a point in the plane, connect those 2 points together, either A cross B or B cross A is fine, because whichever vector you put as your forefinger, the other vector is your middle finger, and your thumb goes up or down. I take the cross product of the two given vectors, dot it with the green vector, that dot product is 0. Remember, P points to the given point, and R is XYZ. This cross product vector is a special name. It's the normal vector. The definition is that normals are orthogonal to tangents. The green vector is a tangent vector for the plane. Writing out the components. And executing the dot product. There's the equation of the plane. Easy, fill in the equation. Cross products are great that way. For tangent planes, things are simpler. Same idea, a point and two vectors make a plane, but now it's a point and two tangent vectors. And we want to identify any other point in the plane. The normal vector is orthogonal. Vector that connects those 2 points. The point 1, 2, 3 lies on a surface, so its gradient is orthogonal. In particular, the gradient's orthogonal to that green tangent vector. Their dot product is 0. Writing out the dot product, there's the equation of the tangent plane. An example to finish it off. X partial, I, Y partial, J, Z partial, K. So my tangent plane at some point on the surface is the gradient dot r minus p. Those are orthogonal, dot product 0, and write out the components. Perform the dot product, and there's my equation.